Hi everyone, my name's David Ramos from Professor Shuri's Social Science 10B class, and today I'm going to be teaching you how to use a chi-square goodness of fit test using the chocolate candies M&Ms. So, in the year 2008, the M&M company actually released a distribution of what the colors in an M&M bag should look like. I found this online, and what it says is that the Mars company has published the average percentage of M&Ms in a bag by color. If a regular sized bag of M&Ms has 48 pieces of candy in it, how many can you expect of each color? Here is the distribution. The color red should be 13%. The color blue should be 24%. The color green should be 16%. The color yellow should be 14%. The color orange should be 20%. The color brown should be 13%. So right here I have my own bag of M&Ms that I bought at the store. And we're going to test it to see if the colors in my bag matches the colors that the M&M company claims should be inside of the bag. So let's get started. Here I have my plate of M&Ms and I've already counted them. And the total of M&Ms I've written down right here, it's 104. The first step of a chi-square goodness of fit test is to calculate your expected values. I've already calculated them. To get your expected value, all you have to do is multiply your total number, which is 104, times the expected percentage, which for this case, 104 times 24% equals 25. So the expected blue M&Ms in a bag should be 25. And we keep doing this for each color. 104 times 20% equals the number of orange M&Ms, which is 21. For green, we should get 17 M&Ms. For yellow, we should have 15 yellow M&Ms. For red, we should have 13 red M&Ms. And for brown, we should have 13 brown M&Ms. The next step is to find your observed. To get your observed, all you have to do is count the M&Ms colors that you actually got. I've already counted all of them, and here they are. So we got 25 blue, which is right over here, 19 green, which are these, 24 orange, all of those. We got 24 brown, we got 8 red, and we only got 4 yellow. So now I'm going to write these down under my observed. So we got 25 blue, 24 orange, 19 green, 4 yellow, 8 red, and 24 brown. The third step in a goodness of fit test is to get the difference between the observed minus expected. We're going to write it down in this column right here. So 25 minus 25 equals 0. That indicates that we have 0 difference between the blue observed minus the blue expected, and we're going to do this for each color. 24 minus 21 is 3. 19 minus 17 is 2. 4 minus 15 is negative 11. We have a lot of difference for that one. 8 minus 13 is negative 5. And 24 minus 13 is 11. Our next step is to square the differences that we just calculated. So 0 squared would be 0, 3 squared would be 9, 2 squared is 4, negative 11 squared is 121, negative 5 squared is 25, and 11 squared is 121. Our next step is to divide our observed minus expected squared by the expected. We're going to do that in this column right here. So for blue, it would be 0 divided by the expected 25, which equals 0. For orange, it would be 9 divided by the expected 21, which would equal 0.4286. And we continue to do this for each color. I've calculated each color, and I'm going to take a second to analyze what we got. So for blue, we got 0. And what that means is that we got what we expected, what the M&M company expected for us to get. For orange, we got close to what the M&M company said we should have got. For green, we also got close to what the M&M company said we should have. But for yellow, red, and brown, we did have a big difference of what the M&M company said we should have had. Okay, so our next step is to get our chi-squared statistic. Our chi-squared statistic is simply all of these numbers added up. So when we add these up, we get 19.96. Our chi-squared statistic is 19.96. Our next step is to find the critical value. We're going to write down our critical value right here. To get our critical value, we use our significance level, which is given to us. In this case, it equals 0.05. And we're also going to need our degrees of freedom, but we have to find this. And degrees of freedom equals categories minus 1. In this case, our categories will be each color that we have. So we have 1, 2, 3, 4, 5, 6 categories. 6 categories minus 1 equals 5. To find the critical value, we use the significance level and the degrees of freedom, and then we go to our chi-square distribution table and we find our critical value. So right here is the significance level, 0.05. Right here is the degrees of freedom, 5. And we put them together to find our chi-squared, our critical value, which equals 11.070. Now I'm going to write the critical value that we just found on the table. Now that we have our chi-squared statistic and our critical value, we can make a conclusion. So to make our conclusion, if our bag of M&Ms matches the expected number of M&Ms said by the M&M company, we have to state our null hypothesis. Our null hypothesis would be that our bag of M&Ms is the same as the distribution of the M&M company. Our alternative hypothesis would be that no, our bag of M&Ms is different from the M&M company. To make our decision, we have to compare the chi-squared statistic with the critical value. If the chi-squared statistic is greater than the critical value, then we have to reject the null hypothesis. In this case, our chi-squared statistic is greater than our critical value, which means that it falls into the rejection region. So we reject the null. Our conclusion is that there is enough evidence to say that our M&M bag distribution is different from the stated M&M company distribution.